So here at the Information Technology Laboratory, really starting out at the strategic level, we're really thinking a lot about how can we utilize advancements in high-performance computing, artificial intelligence, and the network and security requirements across those networks to really transform every mission that we can think of. So how can I utilize efforts in high-performance digital engineering, whether it's designing of a military operation or a system of systems in our infrastructure projects, down to the individual components, weapon systems, vehicles, infrastructure components that may make that up, all the way down to the way that we're going to manufacture those. And so critical to that, of course, is the design of them, how that's going to be enabled by high-performance computing technology so we can design them better, faster, and cheaper.
Whenever you're thinking about the factory of the future, there's all these steps, these processes in their manufacturing cells, and one manufacturing process feeds the next one, and the next one, and the next one. But at the end, what you normally do is quality control and inspection, right? And so in order to do that, we've developed a couple of computational tools, a framework, if you will, that does in situ sensing and monitoring. All of that information tries to understand, what's happening during the printing process, so you can find those key performance drivers that are giving you good quality or bad quality. And then we feed all of that into a data warehouse that is spatial and temporally indexed. So, if you want to look at things in time and space, you can pull out point clouds of information and then feed it into some AI ML analytics. So we have a lot of data science tools. What that does is it helps us understand exactly what's happening in the process. In the end, what we're trying to do is get to this machine control, and we need all that information for the training. And we use that to do things like digital twins and closed loop feedback controls.
We know that artificial intelligence and machine learning is going to help us do that. And it's going to help fill in a lot of knowledge gaps for complex processes that even today we don't understand the physics and chemistry and first principles of. And so AI ML can help us with that. And then as we push information around these ecosystems, we need to make sure that it's secure, particularly for our critical infrastructure and national security applications. And so our team has been working across, from the factory floor and the operational technologies, the machines that are going to be doing this manufacturing, the networks that connect those machines, the software that actually does the designs and pipes those designs into the machines. How do we ensure that that whole connected network is secure from a cybersecurity perspective? So one of the long-term goals in our development of this technology is if we can have onboard computers and models that are running in tandem with manufacturing, we can take what would have conventionally required a team of engineers, a testing laboratory, and a lot of time and effort and deploy it anywhere in the world. And so when you think about an aircraft carrier operating in the Pacific or a forward operating base, we have soldiers that need parts, we have sailors that need parts that are for critical requirements that they have. They can produce those parts, and all of these models are providing all that expertise where they need it at the point of need to support their mission requirements.